Okay, in the previous video, we looked at alkanes and naming alkanes and drawing some of them. In alkenes, or in this video, we're going to learn about alkenes. Now, these are very similar to alkanes, but if you remember from that introduction bit in our previous video, you might know that alkenes have at least one, so at least one double bond between the carbons. So at least one carbon double bond. Right? So when you have this, you know that it automatically fits into the criteria of an alkene. Now, the general formula, and this formula only works if you've got one double bond in your compound, is if you've got CN, it would be H2N. Right? So if I've got C5, this would be H10. If I have C5H10, I'm looking at an alkene that has one double bond, right? So the prefixes that we learned in the previous video actually apply to these as well, right? So if I'm looking at the number of carbons, I can associate these names with those number of carbons in my alkene as well. The one difference, or one of the differences, is that the ending for an alkene ends in ENE. So instead of it being ANE, as we saw for an alkane, the ending for an alkene is ENE. So butene might tell you something. There's a 4-carbon molecule, and then there's a double bond as well. Now, another difference between alkanes and alkenes is that you have to specify where in the molecule the double bond would be, right? So when we take a look at a few examples, we'll see how we can number them. But before we go on, I just want to bring your attention to the fact that there is no methene. So there's no methene, but I want you to think about why. The reason is pretty obvious. It has to do with the number of carbons, but you should be able to explain to me if I ever ask you, why is it that we don't have a methene? Okay, so having said that, let's take a look at our first example. So as you can see, I've drawn it as a line diagram. I've tried to make those dots a little bit more obvious to you in case you're concerned about being able to identify the carbons. But let's see if we can name this particular molecule. Now, I see that there's at least one double bond in the molecule, right? So because I know that, I am going to number them so that I want my double bond to have the least possible number of all the possibilities, right? So I'm going to start numbering it from left to right. So if it is 1, 2, 3, 4, 5, 6. So that would be if I go from left to right. Or what if I go from right to left? So if I go 1, 2, 3, 4, 5, 6. Now, because this double bond is right smack in the middle, it doesn't matter if I number it from left to right or from right to left. My numbers are both still the same. It's either 3 or 4, whichever way I do it. So I'm just going to cross out one of the directions. Let's say I'm going to cross out the left to right. Doesn't matter though, because I could just keep whichever one. So 1, 2, 3, 4, 5, 6. Let me cross that out. So I only have one number, so that way I'm not confusing anybody. Now, between these two numbers though, if I'm ever telling you where the double bond is, if I'm trying to identify the location, I want to go with the number that's less of the two. So this double bond is between 3 and 4. So when I'm describing where this is located, instead of me saying between 3 and 4, I'm going to say at carbon 3. So you should automatically know that that's between 3 and 4. So when I'm naming this particular compound, I'm going to go with the number of carbons there are. So let's start with that. So there's 6 carbons. So that would be hex. So that's my prefix. I know that there is at least one double bond. So I'm going to use my ENE ending. So it's a hexene. But I have to specify where exactly that double bond is. So because of that, because I just told you it's between 3 and 4, I always choose the less of those numbers. So the 3 is less than 4, so I'm going to write 3-hexene. That is the name of this particular molecule. You might also see your textbook do this, so you'll see the naming as hex 3-ene. That is also correct. So you can see both of these names are appropriate. So this is how you would name this particular molecule. You always want to number your molecule such that your double bond has the lowest possible number, right? Just like in our previous, when we looked at alkanes, you wanted our side groups to have the lowest possible number. Same thing here. You want your double bonds to have the lowest number as well. So if you take a look here at this next example, I want you to try it. So maybe pause the video and give it a shot. And then when I take it up, you'll see if we got the right answer or not. So what we want to do is always include our double bond in our longest continuous carbon chain. So if we take a look here, I might be inclined to number it 1, 2, 3, 4, 5. Now, doing this excludes the double bond from the longest continuous carbon chain. I do not want that. I want to make sure that my longest continuous carbon chain contains that double bond. So there's, again, a few ways that I can do it. I'm going to show you both of them. Eventually, I'm going to stop showing you both of them. This is just so you can get your mind thinking into how you could possibly name these or number these, right? You want to get familiar with thinking of all the possibilities. You don't necessarily have to write down all the possibilities, but you should be thinking to make sure that you have the longest possible chain. So I could number it 1, 2, 3, 4, 5, or I could number it 1, 2, 3, 4, 5. Right? Again, a few different possibilities. If I'm numbering it from right to left, that means that my double bond is between 4 and 5, carbon number 4 and carbon number 5. If I'm numbering it from left to right, I know that my double bond is between carbon number 1 and carbon number 2. So the choice is pretty obvious to me. I want to number it so that the double bond has the lowest number possible. Right? That's what I'm concerned about. Now you'll notice that this CH3 here is not part of our longest continuous carbon chain. So that means that this is a side group. And because it has one carbon, it is a methyl side group, right? And when we are naming our side groups, we want the YL at the end of it. Okay, so let's name these. So I am going to start with the longest continuous carbon chain. So how many carbons is that? That's 5. So I've got pent. I see that there's one double bond, so that's pentene. My double bond is at carbon number 1. So 1 pentene. But I also have to include my side group here. And I also, just like I learned in alkanes, I have to specify where that is attached to in the carbon, the longest chain, right? So which carbon is this attached to? In the numbering sequence that I have here, the way that we numbered so that the double bond could have the lowest possible number, it is attached to carbon number 2. So this is going to be 2-methyl. Right? And because I'm separating a letter with a number, that's got to be a dash. So 2-methyl-1-pentene. Okay, now here's another example. This time I've got 2 double bonds here. It's also a line diagram. I'm going to try numbering it from left to right and right to left. So in doing it from left to right, I've got 1, 2, 3, 4, 5. So my double bonds are at 2 and 4 positions. For right to left, I've got 1, 2, 3, 4, 5. So my double bonds are at 1 and 3. So 1 and 3 is less than 2 and 4, right? So I'm going to go with the sequence that allows me to get my double bonds at 1 and 3 locations. So because of that, I've got 5 carbons, so that's pent. Now here's the difference. I've got 2 double bonds. So instead of just writing pentene, I'm going to write pentadiene. So pentadiene. And I have to specify this die is mainly just for me to know, or the person looking at it to know, that I've got 2 double bonds in this particular structure. And I want to specify which location. So that's going to be 1, 3 pentadiene. Okay, so that's that's a few examples on alkenes. We'll do more examples as we learn a bit more about more functional groups, and we all put it together and learn a little bit more. Okay, so try and do some of the practice that you see on D2L and see if you get the right idea here. All right, bye.